Greetings and welcome to Chapter 9, Lesson 9.2, Outcomes and the Type 1 and Type 2 Errors for Hypothesis Testing. Get to know the new terminology for this lesson. Click on each of the words, learn its definition and meaning. When you are ready, click Continue. There are two possible errors that can arise with hypothesis testing, a type 1 error and a type 2 error. Now that comes along with testing the H0, and there are two possible outcomes to test H0. You can either fail to reject 0, in other words, H0 is good, or you can reject H0 and you can consider H0 to be bad. So if you kind of think of it as good and bad, fail to reject your H0, that means it's good. Reject H0, that means H0 is bad. You can throw it out. The reality of H0 is something different than our test. Those two things are separate. Just because our test says that H0 is good or bad doesn't mean the reality that H0 is good or bad aligns all the time. That's when these errors creep up. Let's say H0 is actually good, and we fail to reject H0 in our test, meaning H0 is good. That's great. That's exactly what we wanted. H0 is good. We tested it and said H0 is good from our outcome. Those two match up perfectly. Now, if H0 is good, but our test rejects H0, thinking that it's bad, that's what's called a type 1 error. H0 is really good, but our test says it's bad, and those two things don't match up, and that's a type 1 error. On the other hand, if H0 in reality is bad, we test it and we fail to reject it, in other words, H0 is good, that is a type 2 error. H0 is bad, but we say it's good from our test, and that's a problem. That's an error. That's a type 2 error. But if H0 is bad and we reject H0 and we say it's bad, then that's a correct outcome. Our test aligns with the reality of what H0 is. So if the reality aligns with our test results, that's great. But if they don't line up, that's bad. We're going to use alpha as the probability of type 1 error, and beta, the next Greek letter, to equal the probability of a type 2 error. Now remember, type 1 error is the probability of rejecting our null even though the null is true. And a type 2 error is not rejecting null when the null hypothesis is false. If you've ever heard of a false positive, that's what this type of errors are, is like a false positive. Now, let me talk about an example that most people can at least follow along, if not identify with. Let's say H0 is you're pregnant, and you're going to go down to the local store and you're going to get a pregnancy test. Let's say you are pregnant and you take this pregnancy test and it comes out positive. Well, you are pregnant, the test came out positive, and therefore that's the correct outcome. But what if you're pregnant and that test came out negative? That is a type 1 error. A false negative is a type 1 error. Now let's say you're not pregnant. There is no way possible you are pregnant, and the test comes out positive. That's a type 2 error. That is a false positive. Now, if you're not pregnant and the test comes out negative, then those work out just fine. That's a correct outcome. You're not pregnant, the test is negative, everything's good. But if you're not pregnant and you get a false positive, that's a type 2. If you are pregnant and get a false negative, that's a type 1. Hopefully, possibility of these type 1 and type 2 errors are starting to kind of sink in a little bit. Let's put a scenario around type 1 and type 2 errors. Let's say our null hypothesis is Frank's climbing equipment is safe. Now, that doesn't have to do with the reality of the equipment. This is just our hypothesis. We're going to test our hypothesis. So we test our hypothesis, and Frank believes it's unsafe. That is a type 1 error. We suppose our hypothesis is that it is safe. We test it, and Frank thinks it's unsafe, but in reality it's safe. Well, the consequence there is Frank just won't go rock climbing. Okay, he won't see the view from a beautiful height, but the consequence is he won't go rock climbing. Now let's take that hypothesis and turn it into a type 2 error. A type 2 error is Frank thinks it's safe when in all actuality, the equipment is not. That is a type 2 error. Frank thinks it's safe, but in all actuality, it's not. That has more consequence to it. Why? Because if Frank thinks it's safe, more than likely he'll use the equipment to go rock climbing. If the equipment is not safe, there's a possibility that he could get hurt. So the consequences for the type 2 error in this case are greater than the type 1 in this case. Now, it's not always the situation that type 2 has greater consequences. It does depend on the scenario itself. All right, let's go through a full example. It's a boy. Genetic labs claim to be able to increase the likelihood that a pregnancy will result in a boy being born. Statisticians want to test this claim. Suppose the null hypothesis is age 0 is it's a boy. Genetic labs has no effect on gender outcomes. A type 1 error is when age 0 is true, but we say it's false from our test results. So in that case, we believe it's a boy labs influences gender outcomes, when in fact they don't. This is a type error, a type 1 error, and it equals alpha. Let's look at what a type 2 error is. That's when H0 is false, but we say it's true. So that would be something like, we believe it's a boy. Genetic labs does not influence gender outcomes of a pregnancy, when really it does have an effect. That's the probability of type 2 error is beta. Which one has the greater consequence? Either it influences gender outcome when in fact it doesn't, or it does not influence gender outcome when it actually does. Which one has the greater consequences? Well, there's two frames of mind here. You could consider type 1, since couples would like to use It's a Boy's products in hope of increasing their chances of having a boy. But you could also say it's type 2. Here's why. From the perspective of It's a Boy genetic labs, if we do some testing and we put it all over the news that they don't have any influence on gender outcome when they do, that can really hurt the company. It doesn't hurt the customers, but it could hurt the company. And type 1 might hurt the customers instead of hurting the company. So it actually does depend for this one, in my eyes, which perspective are you looking at? Are you looking at it from the customer's point of view, or are you looking at it from the company's point of view? Let's look at another example, this one a little bit more serious. A certain experimental drug claims to cure a cure rate of at least 75% of males with prostate cancer. We're going to describe type 1 and type 2 errors and which error is more serious. Now, H0 would be, has a cure rate of at least 75%. for males with prostate cancer. Remember, type 1 error is when H0 is true, but we say it's false. So in context, the cancer patient believes the cure rate for the drug is less than 75% when it actually is at least 75%. Now, type 2 error is where H0 is false, but we say it's true. And in this case, if we say it's true, but it's really false, then a cancer patient believes that the experimental drug has at least a 75% cure rate when the cure rate is less than 75%. Now, in this scenario, a type 2 error might have more severe consequences. Here's the reason why. If a drug is not as effective than what we think it is, what we say it is, then that could influence the patient and the doctor's choice about whether to use the drug or not. So let's give you true numbers here. Let's say our hypothesis is the cure rate is at least 75%, but the actual cure rate is 10%. That would actually have a more severe consequence because the patient believes that it's 75%, when in reality it's only 10%. And the doctor might prescribe it as a drug treatment more. So because thinking that it has at least a 75% success rate, when in reality it only has a 10% success rate. So in this case, a type 2 error can be more consequential. Now, granted, if we say that it doesn't have a 75% success rate, but it does, that's actually better for the patient, right? So they take the drug and they're getting a better success rate than they thought they were getting. So in this case, a type 2 is more severe. Now, I normally don't go over the questions that you work on, but this time I just want to make sure you understand why the correct answer is the correct answer. Our hypothesis is a patient is not sick. In a type 1, we're going to reject this when it's actually true. Since the H0 is true, it means the patient is not sick. Okay, the patient is not sick. We tested them to see if they're not sick, but our test was rejected, meaning that we conclude the opposite, that the patient must be sick. That is a type 1. The patient is not sick, but our test says they are. A type 2 is failing to reject H0 when it's false. Since being false means our patient is sick, and we test it to see if they're not sick, and we decide we don't reject that, we say they're not sick. The problem is the patient is sick, and our test said they weren't sick. In this case, depending on how you interpret it, type 2 has greater consequences. Now, if you're not sick and we say you're sick, sure, a doctor might give you some medicine, but in general, the medicine will probably not hurt you to take it if you're well, and it's not going to really hurt you. But if you are sick and a test comes back and says you're not sick, then the doctor is not going to give you the medicine you need to get well. That has greater consequences. Now, that's not to say that a patient who's not sick takes medicine that couldn't be harmful. I'm just saying in this generic situation, a patient being sick and a test coming out to say they are not sick, that has greater consequences because the doctor won't give them the medicine they need to make them well. So the correct answer is type 1, patient is not sick, but we say they are sick. Type 2, patient is sick, but we say they are not sick. And type 2 has greater consequences. You've reached the end of this lesson.